All right, students. So we're going to talk about local extrema. They can only occur on an open interval because a derivative is required to find the local extrema. So since you cannot take a derivative of an endpoint, that's why a local extrema cannot occur on endpoints. So you will always be looking at an open interval from A to B. Now, absolute extrema can occur on a closed or open interval. It's determined by the y value of the point. So since a derivative is not required for absolute extrema, then it can happen on a closed or open interval. Now, oftentimes you are asked to find absolute values for closed intervals. So there's something called a closed interval method. So this is the closed interval method. Its purpose is to find the absolute extrema in a closed interval of A to B. Okay, and so you can find this information on a red box on page 282. Now, the first step is to find your critical numbers in AB, the open interval. How you do that is you take your derivative, set it equal to 0, and find what x value would make it 0. Or take your derivative and see if it does not exist, and at the x value that it does not exist, that would be a critical number. So once you have your critical number, then find the critical values. What is values again? That is the y value. The next step is to find the values of the endpoints. So you would take the values of the endpoints, f of A and f of B, and find out what those are. And then the third step is to take all of these values that you got and compare them and find out which one is the lowest value, that would be the absolute minimum, and which is the highest value, that would be the absolute maximum. So let's do a problem, okay? So there's example 4 in your book, but this is my version of example 4. So here's the problem. You have this function f of x equals 3x to the fourth minus 16x to the third plus 18x squared. And this is a closed interval of -1 to 4. So in other words, -1 to 4, like so. So it has 3 parts. Part A, find all absolute extrema. Part B is find all local extrema. Part C is use the information in part A and B to sketch the graph of f of x. Okay, so this is what we are going to do. Part A is to find the absolute extrema. So part A, you are going to use the closed interval method. So what is the first step? You need to find the critical numbers. So take the derivative, set it equal to a 0 or does not exist. So when you take the derivative of the original function, this is what you get. 12x cubed minus 48x squared plus 36x. Okay, since this is a polynomial, there is not going to be a point in here where the derivative does not exist, because polynomial is a nice smooth curve. All right, so now what we do is we set it equal to 0. So we take our derivative, set it equal to 0, and I already started factoring. So when I factor, then this is it completely factored down. And so now I found the critical numbers. The critical numbers are x equal to 0, x equal to 1, and x equal to 3. So now the next thing I need to do is I need to find the critical values. So what is f of 0? I put that back into my original function. So it's going to be 3 times 0 to the fourth minus 16, 0 to the third, plus 18, 0 being squared, which is 0. So that is a value. Do the same thing for 1. So 3, 1 to the fourth minus 16, 1 to the third, plus 18, 1 being squared, and you get 5. That is a critical value. And then you do the same thing for 3. You do the same thing, and you end up getting -27. So those are your critical values, which are all also y values. So it's important for you to remember, values means y value. That's what we're talking about. Okay, so that is the first step in our closed interval method. So now, what is the second step? The second step was to find the values of the endpoints. So since the interval was from -1 to 4, then we're going to find f of -1. And when you put -1 in, you get 37. And when you put 4 in, you get 32. So values of the endpoints. Okay? Now, the third step in this closed interval method is to compare the values you get in step 1 and 2. So what I usually do is I put them in order of their x values. So I do this. I go f of -1. That would be the first one. Then the next one would be f of 0. Then the next one would be f of 1. Then the next one would be f of 3. And then the last one would be f of 4. So f of -1 is 37. F of 0 is 0. This is 5. This is -27. And this is 32. So since this method is used to find the absolute extrema, then all we have to do is compare all these values. Which one is the highest y value? That would be this guy right here, which is an endpoint. So 37 is an absolute or global maximum. 37 is equal to f of -1. You can also write f of -1 is an absolute or global maximum because both of these represent y values. You cannot write x equal to -1 as your answer. That is not correct because it's not a value. It's an x value, but what is the highest y value? That is not the correct answer. So no. Okay? So that is an absolute maximum. Now we look at all of these and we try to find which one is the lowest. And that's right here. -27 is an absolute minimum. Or you can say f of 3 is an absolute minimum. Okay? This is the highest y value. And this is the lowest y value. Okay, so that is part A. Now we need to do part B, and I'm going to do that in the next recording.